All right, let's get right into it. Today, we're diving into a problem that's giving even the best software architects a serious headache. How on earth do you build something solid and reliable when your main tool, well, when it's as unpredictable as a large language model? I mean, this quote just nails it, doesn't it? Trying to build a bridge out of sentient fog. It perfectly captures that feeling of anxiety. Imagine you're an architect, someone like John, and you've spent your entire career building with solid, predictable code. Bricks and mortar, you know? And then suddenly you're handed this new material, a material that thinks, a material that has moods. It's like the fundamental laws of physics just went out the window. So let's stick with our protagonist here, this architect named John. For 20 years, his entire career has been built on one simple, beautiful rule: loose coupling. It's basically the golden rule of modern software. But when he started working with LLMs, it felt like he was being dragged back into the dark ages. Instead of these neat, separate Lego bricks he was used to, he was handed this giant, messy, monolithic block of English. So what is this loose coupling thing he's so passionate about? Well, it's actually a pretty simple but incredibly powerful idea. Think of it like a team of specialists. The heart surgeon doesn't need to know how the brain surgeon does their job. They just need to trust that the other person will do their part. In software, this means different components don't need to know the messy internal details of each other. They just communicate through clean, simple agreements. That way, you can fix or upgrade one part without, the whole patient falling apart on the table. And here's the difference in a nutshell. On the left, you got that tightly coupled monolith. It's a tangled mess, a fragile house of cards. You touch one thing and the whole thing comes crashing down. But on the right, that's the world John lives in, a resilient, flexible system made of independent blocks. And you can see why he was so worried, right? He felt like this new AI tech was forcing him to go back to building that fragile, tangled system. And that's a scary thought. Okay, but then he had a breakthrough, a real aha moment. He realized he was looking at the whole problem from completely the wrong angle. And this is where the story gets really good. Here was the big realization. The LLM doesn't have to be the entire application. It can just be one part of it, a very important part, sure, but just the part. Think of it not as the whole orchestra, but as the conductor. Its job isn't to play every instrument, but to direct all the other specialized tools and components. It becomes the CPU, but for logic written in plain English, not machine code. It's a total game changer of a perspective. And when you look at it this way, the benefits just become so clear. That old monolithic approach, it's a total black box. You have no idea what's happening inside, it's expensive, and you're just crossing your fingers hoping for a good result. But with this new modular architecture, wow, you can manage resources better, you can see what's happening at each step, and you can even mix in good old-fashioned reliable code where you need it. It's about bringing real engineering discipline back into the picture. So with this new mindset, John sketched out a plan, a 3-tier model. It's pretty elegant, actually. First, you've got the prompt layer. Its only job is to figure out what the user actually wants. Then you have the agent layer. This is like a team of specialists, a little AI expert for summarizing text, another one just for checking data, and so on. And finally, you have that orchestration layer. That's our conductor, the big LLM, telling all the little agents what to do and in what order. It brings a beautiful structure to the whole process. All right, so the first problem is solved. He's broken down the monolith, but that didn't get rid of the core issue, did it? Each of those little AI agents is still, a bit wild. They're still unpredictable. They can fail. They can make stuff up. They can hallucinate. He needed to figure out how to handle that inherent chaos, and that led him to his second big aha moment. You gotta love this quote, right? A circuit breaker for bullshit. It's blunt, but it's perfect. And this is where John realized something profound. He didn't need to invent some crazy new AI-specific solution. He could just use the same tools he'd been using his whole career. The classic, battle-tested patterns from making systems resilient. His old toolkit would work just fine. He basically built a safety net. The strategy is so smart because it's so simple. Okay, plan A, try the big, powerful, expensive AI model first. If that doesn't work or it's too slow, no problem. We automatically switch to plan B, a smaller, faster, cheaper model. If that one messes up too, we go to plan C, a super simple, predictable rule that we wrote ourselves. And if the world is truly ending and nothing works, we have plan D, just give the user a safe, helpful message. The key is the system never just dies. It fails gracefully, step by step. And look, this isn't some random idea he pulled out of thin air. Each one of those fallback tiers is a classic, well-understood engineering practice. You've got caching to make things fast, degradation to handle load, determinism for reliability, all of it. He was applying time-tested architectural patterns to this brand new problem. He was literally architecting for uncertainty. There was one more piece to this puzzle, though, a contract. He had to force the AI to speak a language the rest of the system could understand. So he used something called a JSON schema. It's basically a very strict set of rules for how the AI has to format its answers. No more creative, rambling sentences. It had to deliver the data in a clean, predictable structure. It's like teaching the sentient fog to fill out a form correctly every single time. Okay, so at this point, the system is modular, it's resilient, it's reliable. He's done, right? Well, not quite. John had one more realization, and it was about the most critical piece of the puzzle, the one he had almost forgotten about, the actual human being using the software. And this is such an important question to ask. While all those fancy AI agents are doing their thing, thinking and collaborating, what is the user looking at? A spinning wheel? A blank screen? Do they think the app just crashed because, a complex task could take seconds, maybe even minutes? That's an eternity for a user. It turns out there's actual science behind this feeling of impatience. Our brains perceive time in different chunks. Anything under half a second feels instantaneous. We're pretty patient for up to, say, 10 seconds. But once you go past that, we enter what's called the execution phase. And at that point, if you don't tell us exactly what's going on, we lose trust. We get frustrated, we leave. So the solution is simple. You have to design for that wait. You have to be transparent. Instead of a generic processing message, tell the user what you're doing. Okay, summarizing your 4 documents now. For really long waits, show them a meaningful progress bar. And this is the big one. Always give the user an out. Let them pause or cancel the operation. It's the difference between a frustrating black box and a transparent, trustworthy experience. And all of this brings John's journey full circle. He started out lost in that sentient fog, feeling like all the rules had changed. But in the end, he found his way back to solid ground. This final thought from him is just perfect. Logic as language. But the architecture is still home. What he means is, yeah, the raw material is new. We're using language to define logic now, not just code. But the rules for putting it all together, the blueprints for building something strong, something that will last, those rules haven't changed one bit. The principles of good architecture are still our home base. So in the end, by just stepping back and relying on those timeless principles, things like loose coupling, building in safety nets, and always thinking about the user, John did it. He tamed the chaos. He took that sentient fog and turned it into something structured, reliable, and actually helpful to people. And that really leaves us all with a challenge, doesn't it? When you start your next AI project, think of it like a raw block of wood. The technology itself is just the material. The real question is, what are you going to do with it? Are you going to get carried away and carve a beautiful but fragile sculpture? Or are you going to be an architect and build a structure that's meant to last?